Alright, YouTube, in this video we're going to continue my module on reference angles, and we're going to dip into what we call the reference angle theorem in this video. And the reference angle theorem listed up here on the top left says that a trig function of an angle and its reference angle differ at most in sign. We'll look at the illustration below, but essentially what this is saying is if we were to say, for example, take the sine of an angle, say the sine of some angle theta, then necessarily it would have to equal the sine of its reference angle, but maybe only different in sign. So possibly positive, possibly negative, but you get the same answer no matter what. Okay, and so this is actually really convenient when evaluating trig functions. So let's go ahead and take a look at an example of what I mean by they can differ at most in their sign, S-I-G-N sign, not S-I-N-E. So as an example, let's take a look at the sine of all angles between 0 and 360, but that have a reference angle of theta party hat here. Theta party hat is 30 degrees, okay? So what you'll see is we have a 30 degree angle, a 150 degree angle, a 210 degree angle, and a 330 degree angle. And recall that a reference angle is the angle formed by the terminal arm of a ray in the x-axis. So you'll notice here, like this has a 30 degree reference, this has a 30 degree reference. All of these have 30 degree reference angles, even though these angles may be like very large. What you'll notice though is this. Remember, these triangles, we can evaluate the sine, say for example, of an angle, the sine of an angle, by taking the y value of a point on the terminal side divided by r, which is r being the length from that point back to the origin here. You'll notice that all of these points that are on the terminal side here all have the same y values. That is, all of these triangles have the same, opposite the reference angle side length, and they all have the same r value or hypotenuse length. Fact of the matter is this. If you were to do y over r for, say, 30 degrees, we say sine of 30 degrees. Taking a look at this triangle over here, sine of 30 degrees, it looks like we have a y value of 1 on our point and an r value of 2. If we were to do the sine of 150 now 150 has a 30 degree reference angle. But over here we say, well, look at this point on this terminal side. If we did y divided by r, that'd be y value of 1. Divided by an r value, distance back to the origin of 2. And you'll notice you get the same thing. And not a shocker when you're looking at the diagram here. They're the same triangle, at least in terms of their dimension. So now if we go down to the third quadrant here and we say sine of 210. We say 210 because 210 has a 30 degree reference angle. In this instance, you'd see that the point on the terminal side is negative radical 3 comma negative 1. So our y value is negative this time, so we'd have y over r would be negative 1. But over r being positive 2. Recall that r is always positive. And then last but not least, if we were to go down into the fourth quadrant and do sine of 330, which also has a reference angle of 30 degrees, what we'd say is y over r. Our point is positive radical 3 comma negative 1. But in this instance, we get y is negative 1 over a positive r value of 2. So all of these, really essentially what we want to say is this. If they have the same reference angle, then when you take the sine of something that has the same reference angle of another thing, you'll get the same numbers. You'll always get the same numbers, okay? So the only thing that can be different about them is their SIGN sign. So like this was negative, this was negative, this was positive, this was positive. And as a matter of fact, using a mnemonic that we use often in trig, this all students, if you've not heard of this, all students take calculus, essentially this says that all trig functions are positive up here. Sine is the positive one in quadrant 2. Tangent is the positive 1 in quadrant 3, and cosine is the positive 1 in quadrant 4. I could have told you now, taking the sine of all of these, they all come out to be a half because they have a reference angle of 30 degrees, but the reason why sine of 210 and sine of 330 came out to be negative down here and here is because in these two quadrants, sine is negative. Up here we have sine being positive in the first and the second quadrant. So kind of a good lead in to excuse me, reference angles, but let's take a look at this right here. What I've done is I've outlined 4 steps for evaluating for the exact value of a trig function. Okay, and if we follow these 4 steps, we can actually use the reference angle quite a lot of the time to evaluate a trig function. And the reason why we'd want to use the reference angle instead of the actual angle is because the reference angle, recall, theta party hat, is always between 0 and 90 degrees. And we know, say, the sine, cosine, and tangent of angles between 0 and 90 degrees a lot easier than we know, say, the sine, cosine, or tangent of angles that are, way over 90 degrees. So here's the way this works. We'll just go ahead and take a look at this first example. We say find the sine of 240 degrees. Not just the sine, but the exact value. Exact value means no decimals. We want the actual value of this. So the first thing we're going to do is we're going to sketch in our 240 degree angle before we go through my steps up here. So 240 degrees. A good way to put it is 180 plus another 60. It'd be down here in the third quadrant. So here's our 240 degree angle right here, 240 degrees. Okay. So the first thing we want to do is this. Step one, we're going to find the reference angle for our given angle, 240 degrees. So if theta is 240 degrees, let's go ahead and list that out. Then theta prime, or theta party hat, okay, we would get as this positive acute angle between the terminal arm and the x-axis. So it's kind of like if we dropped an altitude here. It'd be this angle right here. And we said that this angle right here, this reference angle, okay, was 60 degrees. So we say 60 degrees is our reference angle, 60 degrees. So now that we've got the reference angle, number 2 here says we're going to determine the sign of the trig function based upon what quadrant theta terminates in. So looking at this, we say, well, all students take calculus. We are currently finding the sine of this angle. And so what do we know about angles that terminate down here in the third quadrant? Well, we know tangent is positive, but everything else is negative, okay? So we say sine would be negative. So we say sine is negative. Okay, so step 1 done, we've got the reference angle. Step 2 done, we say sine is negative. Step 3 says this, write the original trig function in terms of the reference angle theta party hat. Okay, so what we mean here is this. We're going to take the original trig function. I'll scoot down here a little bit. We say sine of 240 degrees. We're going to take this and we are going to rewrite it in terms of the reference angle. And the reference angle is 60 degrees. So we're going to say equals the same thing as sine of 60 degrees, and then we're going to call this negative because sine is negative in the third quadrant. So now, doing this, we could say, well, evaluate. Step 4 is evaluate. Find the value of this. Sine of 60 degrees is one of these ones that we should have memorized off the top of our head. So we say sine of 60 degrees is radical 3 over 2, and then we'll just call it negative. So in other words, to do the sine of 240, you're going to get the same thing as the sine of 60 in the first place because they have the same reference angle. It's just that we have to call our answer negative because sine terminated in the third quadrant, and sine is negative in the third quadrant. So let's take a look at a couple of other examples here. We'll do one with tangent. We say go find the exact value of the tangent of 315 degrees. So the first thing we'll do is we'll sketch in our 315 degree angle, which by the way, is 45 degrees short of a full 360. So we say here's our original theta equal to 315 degrees. So we say it has a reference angle, or theta party hat, or theta prime, of 45 degrees. So now knowing this, we say, well, first of all, identify theta prime. Well, if theta, let me get out a zoom tool here. If theta equals 315 degrees, then we say identifying theta party hat, we say is 45 degrees. The second thing we wanted to do was this, identify the sign of this trig function in the fourth quadrant. Now we're doing tangent, and tangent in the fourth quadrant, we say all students take calculus. Well, the only thing that's positive down here is cosine, so tangent would be negative. So we say tan is negative. This is important. Okay, that is a G. It's supposed to be a G. And so we'll rewrite the original trig function now, which was tangent of 315 degrees. Let's rewrite this as equal to the same exact number you would get as if you did the tangent of the reference angle, since they have the same reference angle. Just that now we're going to call this answer negative. So we say, well, what's the tangent of 45? Well, tangent of 45, anybody that does trig knows that this is an isosceles triangle here. So we get tangent of 45 is 1, and then we'll just call our answer negative right here. Okay. And then this last one here, I just want to look at what we do with a reciprocal trig function. If I was asked to find the cosecant of 300, first thing we do is this. We'd say, well, it's the reciprocal of the sine of 300 degrees. So why don't we go ahead and start by sketching our image here. We say 300 degrees, that would be 60 degrees short of 360. Let's put it in red here. So we say here's our 300 degree angle. Say 300 degree angle, and this is theta. So we know theta prime is 60 degrees, or theta party hat is 60 degrees. So let's say we wanted to do cosecant. Well, what we know is this. The cosecant of 300 degrees using our reciprocal identity is the same thing as 1 over the sine of 300 degrees. In other words, we'd have to find the sine and then reciprocate it, and we'd have cosecant. So let's go ahead and do sine of 300 degrees. We know this. We know theta is 300 degrees. So step 1, let's identify the reference angle, which is 60 degrees. Okay, so we have the reference angle. We say, well, what's the sign of positive or negative of cosecant in the fourth quadrant? Well, we say all students take calculus. The only thing that's positive down here is cosine. So since cosecant is the reciprocal of sine, and sine is negative in the fourth quadrant, cosecant is reciprocal, or cosecant down here is negative. So we say CSE is negative. You know, it's not always negative. I just do examples where it's negative. So now we're going to rewrite this sine of 300. We'll reciprocate when we're done. Sine of 300, we'd say sine of 300 would have to give us the exact same number as if we did sine of its reference angle, which is 60 degrees, except for we need to call it negative. So we say sine of 60, we know this one from earlier, this is negative radical 3 over 2. Whoops, I meant to put my negative out front, but when I said negative, I wrote it in here. We say radical 3 over 2 is sine of 60. We'll call this negative. So this is the sine of 300 degrees right here. We need the cosecant of 300 degrees, so we're going to reciprocate this, and so we get the cosecant of 300 degrees is equal to the reciprocal, which is negative 2 over radical 3, which is the same thing after rationalizing here as negative 2 radical 3 over 3. And sorry to bury this all in here, but that's how you'd use the reference angle to evaluate trig functions.